Hello everyone, welcome back. My name is Horace, and in this video we're going to be going through LeetCode number 3, longest substring without repeating characters. So for this problem, we're given a string s, and we're tasked with finding the length of the longest substring without repeating characters. So the problem is very simple, but we'll go through a few examples to help demonstrate the algorithm. So if we look at the first example, it's not hard to see that the longest substring is of length 3. So one substring could be ABC. There's also CAB. So we just have to find one of them, but the longest is of length 3. Well, how do we find that? Well, one way to find the longest substring from a string is to list out all the substrings and just take the largest one. So for example, if I list out all the substrings for this string s, we'll see that we have A, AB, ABC, all the way until the initial string itself. What if we start the substring at character B? Well, then we have B, BC, BCA, all the way until the end of the string. Going through the second example, we can also clearly see that the longest substring is of 3. Again, we can use this algorithm of listing out every single possible substring. So P, PW, PWW, all the way until we get the string itself. Or if we start at, let's say, K, KE, KEW. So these are all the substrings for this string. We just want to pick the longest one that has no repeating characters. So KEW has no repeating characters, so it is going to be a maximum of 3. And obviously there's more, but you'll see that this is the maximum. If we write out this algorithm in pseudocode, we can see that this is exactly just a nested for loop. So a for loop going from the start of the string to the end of the string, and another for loop going from some index I to the end of the list. And every time we encounter a character, we need to verify that we haven't seen it before. To do this, we're going to just use a set to keep track of the characters that we've seen. And we're also going to maintain a length counter to keep track of the maximum length that we've seen. So if we've seen a character before, that means it's going to be in the set. So if character is in the set, we can just break out of this loop. Otherwise, we're going to add the character to the set because we haven't seen it before. So sets.add the character. And we're also going to need to verify the new maximum length if it has updated. So we're just going to write length equals the maximum of length and the length of the set. At the end of the algorithm, we can just simply return length. So the set is going to be filled up with characters. So for example, A, B, C, but if we encounter another A again, then it's going to already be in the set, and we're going to just break out of this loop and continue from B. So if we do a time complexity analysis, we can see that this is going to run in O of n cube, worst case, and O of n squared on its average case. This is because we're using a hash set, and hashing in the worst case is going to be O of n. Although this algorithm is not the fastest, I'll show you guys how to code it up right now. Okay, so we can go ahead and code up a brute force solution. We're going to first initialize a variable that's going to maintain the longest length that we've seen for the substring. Then we're going to loop over the entirety of the string. We're going to create a set to maintain the characters and maintain unique characters. Then we're going to loop from some index I to the end of the list. and we want to check if the character has already occurred. That means it's going to be in the set. So if s of j is in cur, meaning it's in the set, then we're just going to break out of this loop. Otherwise, we can just add it to the sets. We can update the length. And finally, return the maximum length of the substring. Let's go ahead and check out if it's accepted on LeetCode. So we'll submit this. And it's accepted. And you can see that it's not the fastest, but again, LeetCode timing is a bit inaccurate. Now that we have a solution that is running in O of n cube worst case and O of n squared average case, we can actually do a little bit better. We're going to use a technique known as the sliding window. So instead of computing all of these substrings for some string s, we're just going to adjust our sliding window depending on if we see a duplicate character in the window. So for example, we'll start our window at the beginning of the string. Has A been seen before? Well, no, it hasn't. So we're going to continue to expand the window. Has B been seen before in the window? No. Same thing with C. But once we get to a duplicate character, we're going to need to adjust our window. Basically, we're going to remove from the start of the window and just add the new character or the duplicate character to the window. This way we can check for the maximum substring without having to compute every single substring in the string. Similarly, for this example, we can begin our window at D. D is not in the window currently. Same thing with V. But once we encounter a duplicate character, we're going to adjust the window. And we can add F as well. So the final window is of length 3, which is exactly what we wanted to return. Well, to code this algorithm, we can keep track of the start of the window. We can keep track of the end of the window. And we can keep track of the index of these characters that we've seen. So we can do that using a dictionary or a hash map. Now the time complexity for this will only be O of n squared in the worst case and O of n on average, because we're just using a hash map and we're doing a one pass. So really we can say that this algorithm is going to be running in O of n. With that being said, we can go ahead and code this up. Now we'll go ahead and code up the more optimal solution. So we can begin by declaring the start of the window as well as the maximum length that we've seen, and we'll initialize that to 0. We'll create a hash map to maintain the characters and their respective indices. We're going to loop over the entirety of the string, and in this case I is actually the end of the window, so we can actually just write this as end. We want to check if the character is in the dictionary. Well, if it is, then we know that it's a duplicate, so we have to update the window. Otherwise, we can just add it to the dictionary. We also need to ensure that the index that we're looking up in the dictionary is not past or before the start of the window, because we can't go outside of the window. So basically, we need to check if the character is in the dictionary and if the index that we're looking up is greater than the start. Next, we need to update the length as we did in the previous algorithm. And this time we're going to check the difference between the end of the window and the start of the window. We also need to update the start of the window itself. This is going to be one more than the duplicate character index that we've already stored in the hash map. Basically, it's just going to be start equals the index of car, basically the duplicate character, plus 1. Finally, we can always update the index for some character, and we can return the maximum length or the length minus start. Now this is just to ensure that if the final substring is at the end, we need to just check once again before we exit the loop. And we can go ahead and check this on LeetCode. And you can see it's accepted, and it is a bit faster. This is the optimal solution. It's going to run in O of n on average. And this is also going to take O of n space because we're keeping a hash map, which can be populated with n elements if they're all unique. With that being said, hopefully you guys learned something and my explanation was clear, and I'll see you guys soon.